Hello my dear students, welcome to YouTube channel of eCareerPoint-English medium. So how are you all? Good? Today I'm going to start this chapter, motion in one dimension, which is basics. It's one of the basics from 11th class. So I can see, hello Sanjana, hello Himal, hello Sahil. Okay, so share this session to all of your friends so that all can take the benefit of Kota coaching live directly at your home from YouTube. Okay, so as you know, we have started this new channel for English medium students, especially from South and other NRIs. So in this batch, Nikhil sir will take your chemistry class, Krishna ma'am will take your bio class, and me, Sumit Talwani, I'll take your physics class. And I'm going to start this chapter, motion in one dimension. Okay? Good, Sahil, very good. So, I want all of you to subscribe this channel right now if you didn't have it, because to get notification of upcoming lectures or upcoming Menti quiz. Menti quiz are like online test, so that you can get all the notifications. Subscribe this channel and press the bell icon. Also, we have this amazing app, eCareerPoint Learning app. Okay, this is a very good app, especially designed for this period of Corona. Okay, because using this app you can get very much free stuff. See, these students, these are the regular students of eCareerPoint app, the best live coaching from Kota, and they have scored top 100, under top 100 rank. As you can see, all India rank 34, 38, 41 and 50. These are from our regular class of eCareerPoint. Okay, as I have told you, this is the timetable. This timetable, the 12th class is for Monday to Wednesday and Friday, and this 11th class I will take from Tuesday, Thursday and Saturday. 3 days a week there will be your classes of 11th. Okay, so download this amazing app, because in this app you will get free stuff. Also we have free stuff and paid. So download this app along with Doubt Help. Doubt Help will help you to clear your doubts if you are attending live session from YouTube or eCareerPoint. Okay, so to download, open your Play Store, type here eCareerPoint without any space and open this app. Okay, click on install, and after installing, a registration is required. So do that registration, and after registration follow your experts. Okay, don't forget to follow your experts, because after following you can attempt their questions for free. Okay, and here free stuff, look at this icon, free stuff. In this free stuff you will get all the PPTs. The thing I am teaching here, I am writing here, you will get all these notes in form of PDF here in free stuff. Okay, so let's get started to our lecture from the topic kinematics. What is kinematics? See, kinematics is a branch of physics in which we deal about the study of motion without asking the cause of the motion. For example, we know that this is a sun, Earth revolves around the sun. Okay, this is Earth. What is the cause of this revolution? The cause is gravitational force. And what type of motion it is having? You can assume it is circular motion. Actual motion is elliptical, but approximate it can be assumed circular. Okay, so this cause is not part of kinematics. This motion is part of kinematics. Okay, so in kinematics we only study about the motion without taking into account of the cause of motion. Okay, Sahil, this is kinematics. I am starting from kinematics. Okay. Okay, good, Ujjwal. Very good. So this is kinematics. So motion in one dimension is a part of kinematics. This circular motion we will not study in this chapter, okay, but all the motions, they are in the category of kinematics. Kinematics means study of motion without studying the cause of motion. Okay. Ujjwal, if you are in 12th class, you can attend the classes on Monday, Wednesday and Friday, okay, for 12th batch. Now let us talk about rest and motion. I want to ask you a question. What is the meaning of rest? What do you mean by rest and what do you mean by motion? Suppose if I am standing in front of you, am I at rest or at motion? Think and answer. What is the meaning of rest and motion? If I am standing in front of you, am I at rest or at motion? Sahil is saying when the object is still, then it is said to be at rest. Okay, this definition is okay, but it is not complete definition. Okay, Himal is saying that I am at rest. Sanjana is saying no change in position with respect to time and surrounding. Good, Sanjana. The definition given by Sanjana is more correct. Okay, Himal is saying no displacement. Okay, let me take an example. If you are saying that I am at rest, okay, I am at rest because I am standing on ground, okay, but is ground at rest? You know, Earth is revolving around the sun. It takes approximately 365 days to complete one revolution. So in that reference, am I at rest? Now you will say no. Then who is at rest? Sun? No, even sun is not at rest because it is moving with respect to some other stars. So rest and motion are relative terms. You cannot define rest and motion without taking into the account about observer. Hello Shubham. So see this, suppose there is a train on a platform. Okay, this is the platform and another train is there on the same platform but on the other side. Okay, now suppose there is a man A in this train and there is a man B in this train, and also there is a man standing here on the platform who is C. Now the train has started moving, both of these trains has started moving in the same direction with the same speed. Now see, so as I told you that rest and motion are relative terms. You cannot define rest and motion absolutely. Okay, so in this example, who is moving? A or B or C? Tell me. In this example, who is moving? A, B or C? Hello Kumar Sudha. Hello Shubham Saha. Okay guys, like this session, all of you, those who are live, like this session and share it to all your friends. And answer this question. Among these three, who is moving? See, the correct answer is according to C. A and B are moving, and according to A, B is at rest and C is moving in backward direction. Okay, so this is the correct answer. Okay, Shubham Saha, you are from Techno, very good. Okay, so this is the correct answer, that according to C, A and B are moving, and according to A, B is at rest and C is moving, because with respect to ground, both these trains are moving with same speed in same direction. So A will think that the whole platform along with C is moving backward, but B is at rest. Okay, this is the thinking of A. But C will think that the platform is at rest and A and B, they are moving along with the trains. Okay, so this is the correct explanation. So this is how you should think, because rest and motion, they are relative terms. See this, if I say this balloon with respect to ground is moving here with this velocity, then according to A, B and C are moving, and according to B, C is at rest and A is moving. Okay, this is the correct explanation. So rest and motion are relative terms. You cannot explain rest or motion without observer. You must specify the observer. Generally, we take Earth as the observer. We give the velocities with respect to Earth. Okay. Now, look at this example. As I told you, rest and motion are relative terms. That means a body may seems to be at rest with respect to one object, but may appear to be in motion with respect to another object. For example, this tree. This tree is at rest with respect to ground. The tree is at rest with respect to ground, but with respect to sun, it is moving. Why it is moving? See, this is the sun. With respect to sun, if I observe the tree, then the whole earth is revolving around the sun. So this tree is also moving with respect to sun, but it is moving with respect to sun. Okay? So, let us take another example. If you walk on a straight road, your motion is straight line motion with respect to earth, but it is almost elliptical with respect to sun. Why? Because actual path of the earth is elliptical with respect to sun. So if you are walking and if you are thinking that you are moving in a straight line, then yes, you are correct for an observer which is at rest with respect to earth. But according to sun, all of us, we are moving in elliptical path, almost elliptical path. Is it clear to all of you? The definition of rest and motion. Let me know, is it clear to all of you? Okay. So, another example, the board in the class is at rest with respect to students, but it is in motion with respect to sun. Okay. When you are driving your car is at rest with respect to you, but it is in motion with respect to a man standing on the ground. Okay. Now, so what we can conclude? We can conclude this, that rest and motion are relative terms. Okay. To explain whether the object is at rest or in motion, we have to specify the observer with respect to whom we are asking. Okay. There is no meaning of rest or motion without the viewer. If you are not specifying the observer, we cannot say whether you are in rest or in motion. Okay. Nothing is in absolute rest or in absolute motion. The same thing that I have told you. Now, what is the definition of rest? Listen carefully, because rest and motion, they are defined according to observer. So, the correct definition of rest is if an object does not change its position with the passage of time with respect to observer, then it is said to be at rest. Similarly, what will be the definition of motion? If an object changes its position with the passage of time with respect to observer, then it is said to be in motion with respect to that observer. Okay. So this is all about rest and motion. Now there is a term, as you can see, position. What is the meaning of position? What is this position? So in the chapter vector, you know that position is a vector quantity. Position is a vector quantity. Suppose in front of me there are two students. Student A, which is 5 meters away from me, and student B, which is also 5 meters away from me. So because both of them, they are equally distant from me, it doesn't mean that they are at same position. Defining position, we have to include direction also. Okay. Suppose if I want to define the position of this object, then what should I do? I should assume that I am at the origin of a graph, and with respect to me, the position vector of this point will be the exact position. Okay. To locate the position of an object, we need a frame of reference. Now, what is position vector? See, if you are here and if you want to locate the position of point A, what you have to do? Draw a vector from you to point A. By drawing this vector will be known as position of point A with respect to O. If this particle moves from here to here, then as you can see, its position has changed. The position has changed means the position vector has changed. Because vector quantity, they have direction also. So I can say that this was the old position, this is the new position, and because they are different vectors, so that means definitely there is a change in position. Okay, this R vector, RA vector is the position vector of point A with respect to O. With respect to O means O is the observer. RB is the position vector of point B with respect to O, where O is the observer. Okay, and because the particle has moved from A to B, then this delta R, which is change in position vector, it is also known as position vector of B with respect to A. Okay, see what is delta R? This is change in position vector. This is also known as displacement vector. Okay, if coordinates of A are x1, y1, z1, and coordinates of B are x2, y2, z2, then we can say position vector of A with respect to O is x1 I cap plus y1 j cap plus z1 k cap. This is k cap. Similarly, position vector of B will be x2 I cap plus y2 j cap plus z2 k cap, and difference between them, that is RB vector minus RA vector, it is change in position vector, which is also known as displacement. Okay, so this was position vector. Now, to locate the position of an object, we need a frame of reference. Frame of reference is observer. Okay, when an observer is at rest with respect to frame of reference, then the observer is said to be in that frame of reference. Okay, now, so if this point P is in motion, okay, how to conclude that whether this point P is in motion or in rest? See, with respect to observer, which is generally at origin, if all the three coordinates of the particle remains unchanged as the time passes, then the particle is said to be at rest with respect to frame of reference. Okay? If coordinates are not changing, then we will say it is at rest with respect to this observer, with respect to this frame of reference. If any of this coordinate is changing, that means this particle is having motion. Okay? So, see, let us discuss about types of motion. Types of motion. First of all, we are having one-dimensional motion. That is the name of our chapter. We will study one-dimensional motion. What is the meaning of one-dimensional motion? We should know before starting the chapter. See, it is a motion in a straight line. If a particle is having motion in a straight line, it will be known as one-dimensional motion. Okay? For example, freely falling object along a straight line. If you release a ball from your hand, which kind of motion it will have? It will have straight line motion. Okay, and that straight line motion is also known as one-dimensional motion. For example, this car. If this car is traveling on a straight road, okay, definitely with respect to Earth, then we will say it is having straight line motion or one-dimensional motion with respect to Earth. Okay. Next example, motion of a train along a straight railway track. It is also a straight line motion. So this was one-dimensional motion. That means only one axis is capable of defining the motion. Now, what is two-dimensional motion? It is a motion in plane but not in a line. For example, suppose this car is moving on a road. The car is moving on a road and it is having a circular motion. Now, this is not a straight line. You cannot define its motion from a straight line. You require a plane. Okay, so this horizontal plane, on this horizontal plane, this car is having circular motion. Okay, so we will say that this motion is two-dimensional motion because it is on a plane. Another example, Earth revolving around the sun. Earth, this is sun, and Earth is revolving around the sun in an elliptical orbit, which is also in a plane. So this kind of motion is also two-dimensional motion. Okay. Now, let us talk about three-dimensional motion. What is three-dimensional motion? The motion which is neither one-dimensional motion or two-dimensional motion, neither one-dimensional nor two-dimensional, then it will be 3D motion. That is three-dimensional motion. For example, flying birds. Flying birds do not follow straight line. They do not follow same plane all the time. So their motion is three-dimensional motion. Okay. For example, flying kites. Flying kites is also three-dimensional motion. Now let me ask you one question, that if you are coming to school and you are using your stairs to go to second floor in your class. So from your home to that class, which type of motion you had? One-dimensional motion, two-dimensional motion, or three-dimensional motion? Answer this, use live chat and answer this question. Which type of motion you were having when you go from your bedroom to your classroom, which is on the second floor of school building? Good, Himal. Good, Sahil. Very good. Good, Sanjana. Very good. Definitely it is three-dimensional motion. Why? Because from your bedroom, if you are coming to road, you are moving in a plane. Okay? So you are having a two-dimensional motion. I am assuming your bedroom is on the ground floor. And when you are going to top floor, when you are going to second floor, so you have to leave that ground, which is a plane, and that means that is a three-dimensional motion. Okay. Suppose if an insect is moving on this board in random, if an insect is having a random motion but only on this board, then which kind of motion it is having? 1D motion, 2D motion, or 3D motion? If an insect is moving on this board only, then which kind of motion it is having? 1D, 2D or 3D? Good, very good. It is 2D motion. Why? Because it is moving only in a plane. Okay? So you must be clear about 1D motion, 2D motion and 3D motion. Let me ask you another question. If a particle is having velocity 2I cap, second particle is having velocity 2I cap plus j cap, and third particle is having velocity 2I cap plus j cap minus k cap. Okay, no forces are acting on them, only they are having some velocities. Then which kind of motion they are having? V1, V2 and V3. Which kind of motion they are having? Tell me. If a particle, you know about vectors, if a particle's velocity is 2I cap, you know the axis is, this is x-axis, this is y-axis and this is z-axis. Which of them is 1D motion, which of them is 2D motion, which of them is 3D motion? Answer here. Use live chat and answer like this, separated by comma. Very good. All of these, they are one-dimensional motion. Why one-dimensional motion? Because they are straight line. See, 2I cap means this vector. This is a straight line. 2I cap plus j cap means this vector. This is also a straight line. V3 is 2I cap plus j cap plus k cap. That is also a straight line. So all these motions are straight line motion. Okay, good Sahil, all are 1D motion. They are, this is not 2D, this is not 3D. Why? Because all of them, they are moving in the same line. Okay, so don't do this kind of mistake. They all are 1D motion. Go with the proper definition. If I'm including y coordinate, it doesn't imply that the motion is 2D. No. If suppose a particle is going from this point in a straight line motion, then definitely this vector is cannot be described by single axis. Okay, so this motion will be straight line motion and it will be under the category of 1D motion. Okay. Now let us talk about distance and displacement. Distance and displacement, again an interesting topic. So see, what is distance? Listen carefully. I will ask some questions also. So suppose we are having some axis, because we are observing this with respect to O. We are observing a particle with respect to O. Suppose a particle is moving from point A to point B in a curved path. This is the curved path. Then if I talk about the distance traveled by this particle, it will be the length of actual path. Distance is the length of actual path traveled by the particle. Okay, if you measure this length, this will be known as the distance. Okay, now distance is a scalar quantity because it has nothing to do with direction. Next, for motion between 2 points, distance depends on actual path and so can have many values. Now what does it mean? See, if I want to go from point A to point B, if I choose this path, suppose this distance is S1. If I choose this path, the distance is S2. If I choose this path, the distance is S3. So as you can see, the particle can move from A to B in any path. So distance, it is depending on the path that we have chosen. S1 is less than S2 is less than S3. Okay. So for motion between 2 points, distance depends on the actual path, so it can have many values. Now for a moving object, distance can never be negative or 0. For example, see, if I start moving from this position, I'm moving in this direction, So my distance traveled is increasing as the passage of time. Now, if I take the turn and again I am moving, then also my distance is increasing, because distance is the length of actual path, this plus this. So distance always increases for a moving body. For a moving body, distance can never be negative or zero. Okay, if body is moving, that means distance traveled is definitely a positive value. Also, for a moving object, distance can never decrease with time. See, if I'm moving like this and if I take turn, then also my distance traveled is increasing as the time is passing. It is not decreasing. Suppose this length is 2 meters, then from here to here, my distance traveled is 2 meters. Now again, if I move to my initial position, again I have traveled 2 meters, so my total distance traveled is 4 meters. If I go again here, then my total distance will be 6 meters. So this is how the distance increases with time. For a moving object, distance can never decrease with time. Now, from this information, answer this question. You are having distance time graph and you have to say which distance time graph is possible. Which is possible? See, in first, the distance is initially negative and it is increasing linearly. In second graph, the distance time graph is like this. Third graph, the distance is increasing, then it is constant, then it is decreasing. And the fourth graph, the distance is continuously increasing. Which of these graphs is possible? Which of these graphs is possible? See, let us check one by one. For graph A, as you can see, initially the distance is negative. Okay, it is starting motion from negative distance, which is not possible. So A is incorrect. If we talk about graph B, according to graph B, see, if I ask you what is the distance traveled by this particle at this time t1, what is the distance traveled? See, you are getting two values of distance for a particular time, which is not possible. At a particular time, your distance traveled must be having a constant value. So this graph is also not possible. Now look at this graph. According to this graph, the distance was increasing initially. Okay, distance was increasing initially, then it is not changing. That means particle has stopped. It is not moving. Now, after this point, the distance traveled is decreasing. Is it possible? Can distance decrease with time? No, it is not possible. Okay. Now see graph D. According to graph D, the distance is always increasing. So it is the only correct option. Okay. Good. Very good. Those who have answered correctly, very good. So good. Himal, Sanjana, Kumar, Sudha, very good. So distance can never decrease with time and it cannot have same value. It cannot have different value for a same time. Okay. And also it cannot be negative. Now, let us talk about displacement. What is displacement? Listen carefully. If we are having a frame of reference, suppose observer is at origin. Okay. According to observer, if a particle is moving again from point A to point B along this path, then you know the length of actual path is the distance. But we are interested in displacement. What is displacement? See, suppose particle was initially here and it is going to be. So its initial position vector, which is this, from O to A, which is Ri. Ri is initial position vector. Final position vector is Rf. Then from 9th class you have learned what is displacement. Displacement, you are learning that it is the shortest distance between 2 points. So because displacement is a vector quantity, in vector form we define displacement as change in position vector. What is change in position vector? It is final position vector minus initial position vector. Okay. So if we talk about magnitude, magnitude of displacement is the shortest line joining the initial and final points. Okay, so if we draw an arrow from the initial position to the final position, then this arrow will be known as displacement in moving from A to B. Okay, and because displacement is a vector quantity, definitely it will have a direction. What is the direction? Direction is from initial point towards the final point. Okay, that is why in vector form we define it as change in position vector. Displacement of particle is defined as change in position vector. What is the meaning of change in vector form? It is final minus initial. So change in position vector means final position vector minus initial position vector. Suppose initially the coordinates of the particle which is at A is x1 comma y1, then its position vector will be x1 I cap plus y1 j cap. Okay, so it is initial position vector. Now what is final position vector? If final coordinates of particle are x2 comma y2, then final position vector will be x2 I cap plus y2 j cap. Now according to definition, displacement is defined as the change in position vector. Okay, so in vector form we have to do subtraction. Final position vector minus initial position vector is change in position vector, which is also known as displacement. So as you can see, this is the vector form. Okay, this change in position vector you can write, put the values, you will get x2 minus x1 I cap plus y2 minus y1 j cap. And if I talk about the magnitude of displacement, it should be the shortest distance between A and B. So magnitude, you know how to calculate this square, that means x2 minus x1 square plus y2 minus y1 square. Okay, I have taken this magnitude from this vector form, and as you can see, it is same as the distance formula that you have learned in your previous classes. Okay, so what is magnitude of displacement? It is the shortest distance between 2 points, and if we talk about direction, we have to write in vector form. Direction is from initial point towards final point. Okay, so this is the displacement. So there is a difference between distance and displacement. What is distance? It is the length of actual path traveled, which is a scalar quantity. And what is displacement? It is change in position vector, which is a vector quantity. Okay, now displacement is a vector quantity, so it has magnitude and direction. As I told you, magnitude of displacement is the shortest distance between 2 points, and the direction is from initial point to final point. Clear? These definitions should be clear so that if you want to attempt questions correctly. Now, as you know, only theory in physics is not enough. We have to deal with some examples, good examples. So I am taking some easy example at starting. See, if a particle is moving from point A to point B in this given path, okay, this is semicircle and it is moving in a circular path, okay, of radius r. So you have to calculate what is the distance and displacement of the particle in moving from point A to point B along this semicircular arc. Tell me the answer. There are no options. Himal, it is given that radius is r. So you have to give answer in terms of r. Okay? Good. Sanjana has given answer. Yes, Himal, your displacement is correct. Now give the answer of distance also. See, as you know that distance is the length of actual path. Length of actual path. So what is the length of this semicircular arc? It is half of the circumference of the circle. So distance will be equals to pi into r. 2 pi r is the complete circumference and pi r is the half circumference. So distance is length of path traveled, that is pi r. If we talk about the magnitude of displacement, it will be 2 times r. Why? Because magnitude of displacement means shortest distance between initial and final point. And if these are the axes, then I will write displacement in vector form as minus of 2r I cap, because the displacement is in negative x direction. Is it clear to all of you? The difference between distance and displacement. Okay. Next question for you. Suppose if I am throwing a body upward and it is going up and coming down. Though it is going up and coming down in a single line, but I am showing you it separately so that you can see. Okay, actually it is going up and coming down along a straight line. Okay, this is a straight line motion. So for this complete journey, if its maximum height is h, then tell me what is the distance and magnitude of displacement in this situation. If a particle is going up attaining maximum height h and again coming down at the same position, then what will be the distance traveled by it and what will be its displacement? Tell me. Good, very good, well done all of you, very good. See, distance is length of actual path. So in moving up, its distance traveled was h, and because it is coming down, it is again having some length of path adding. So total distance traveled will be 2h and the magnitude of displacement will be 0. Why? Because it is again coming to its initial position. Shortest distance between final and initial position will be 0. Okay? Now, next question. Suppose this is a fixed wedge, okay, and a block is released from here. Okay, this is fixed. This wedge cannot move. This inclined plane cannot move. Now, if the block is coming down the inclined plane and now it is here, the distance between them, this point and this point, is suppose s. Then tell me what is the distance traveled by it and what is the magnitude of displacement. Think. I am asking displacement in only magnitude. That means you have to find only the shortest distance between initial and final point. Okay. In this journey, what is the distance traveled and what is the displacement of the block? Definitely both of them should be same. Okay, distance is also s, displacement magnitude is also s. Okay, so this is how we can calculate it. Next question, it is a very good question. See, the question says, what is the displacement of the point of wheel initially in contact with ground when the wheel rolls forward half revolution? See the question. This is the ground and there is a wheel on the ground. It is having rolling motion. Okay. What is the displacement of the point of the wheel initially in contact with ground? Suppose this point P is in contact with ground. Now it is rotating and moving. So when it has rotated half a revolution, now it is here. Half a revolution means the point, suppose this is point Q and this is point P. After half revolution, the Q will be in the contact with ground and P will be at the topmost point. So it is asking you what is the displacement of this point P after half revolution if the radius of the wheel is given as r. Think over it and answer carefully. What is the displacement? It is not asking the distance, only the displacement of this point P. What will be the displacement? As you can see the option, only magnitudes are given. There is no vector form. That means question is asking you the magnitude of displacement of this point P, which was initially in contact with ground in half of the revolution of this. So as you know, this when wheel moves, if it is moving perfectly, then there will be no slipping. So this distance will be equals to this distance. Okay, if it is traveling, this distance will be equals to this distance. So I can say this distance is equals to half of 2 pi r, that is pi r. And this distance is the diameter, which is 2r. Now because we are interested in finding out the displacement, the magnitude of displacement is the shortest distance between initial and final points. Between initial and final points, this shortest distance is the displacement. So using Pythagoras, you can calculate this displacement. See, this is pi r, this is 2r. So this displacement, this length AB, it will be under root of pi r square, and that means pi r whole square plus 2r whole square. Okay, so take r common outside and you will get r multiplied by pi square plus 4 as the displacement. So answer is option 2. Okay, is it clear to all of you? Good. So answer is option 2. Use proper definition. Magnitude of displacement is the shortest distance between initial and final point. So from these examples, we can conclude that magnitude of displacement is always less than or equals to distance. Okay? If a body is moving in a straight line, then we can say that distance is equals to magnitude of displacement. Otherwise, if it is taking a curved path, then distance is greater than the magnitude of displacement. Okay, distance and displacement magnitude, they are equal only when particle is having a straight line motion without changing the direction. And if it is taking a curved path, then distance will be greater than the magnitude of displacement. So displacement is always less than, the magnitude of displacement is always less than or equals to distance. Okay. For a moving particle, displacement can never be 0. Oh, displacement can be 0, distance can never be 0. Okay. For example, if it is moving in a circle, then initial point will be equals to final point. In that case, displacement, that is delta r vector, magnitude will be equals to 0. Next point, if S1, S2 and S3 are the individual displacements of a body, then to calculate the final displacement, we have to add these displacement according to vector sum. Suppose if a particle displaces S1 in this direction, then S2 in this direction, then S3 in this direction. Okay, these are the individual displacement. From point this to point this, displacement is S1 vector. From point this to point this, displacement is S2 vector. From this to point this, displacement is S3 vector. Then the net displacement, we will say it is the vector sum of all the individual displacement. Net vector is S1 vector plus S2 vector plus S3 vector. Okay. Now, let me take another example. See, if a car is moving in this path, okay, so this is a path taken which is blue in color. So what will be the displacement? Distance will be the length of actual path, that is shown by the purple dotted line. And what is the magnitude of displacement? It is the line joining initial and final point. This is the displacement. See, if a particle is moving like this, this green line is showing the distance traveled and the blue line is showing the displacement. See, if it starts from here, the distance is always increasing. See? But displacement, because it is shortest distance, it is changing. Initially it was increasing and after some time it was decreasing. So distance can never decrease with time, but magnitude of displacement, it can decrease with time. Distance is always positive, displacement can be negative because it is a vector quantity. Okay? Now another question for you. See this question. If this particle is starting from point O, it is moving to point P, then it is having quarter circular motion, and again from point Q it is returning to point O. So in this complete journey, what is the net displacement of the particle? Okay, it is starting from O, having this kind of path, and the question is asking you the net displacement. Definitely it is 0. Why? Because the initial and final positions are same, so answer will be 0. Okay, so I am now giving you some homework questions. Okay, these questions you have to practice, and practice these questions before coming into next class. Okay, because if you don't practice, you will face some difficulty. So these are your homework questions. This question is your homework and its answer is given. Next question is again your homework, its answer is also given. Again homework question, answer is option 2. Okay, now to solve these homework questions you need these slides. Okay, so you can get these written notes in PDF format. How? What you have to do? First of all, download eCareerPoint app. After downloading this app, how to download? Let me tell you. Search in the Google Play eCareerPoint without any spaces. Then you will find our app. Open this app, install it. After installation, first of all, follow your experts. After following, go to free stuff. When you go to free stuff, you will see these free stuffs. In this free stuff, you will get the notes of this lecture. Okay? So, subscribe to our channel if you haven't did it, and share this session to maximum of your friends. Like this session and comment this session. What do you want? Menti quiz or any other chapter, specific topic if you want to study in this channel. Okay, so this is Sumit Talwani signing out, and before coming to next class, complete your homework. Okay, and for homework you have to download eCareerPoint app. Okay, so this is Sumit Talwani signing out. Thank you very much.